Hello and very good morning. Today I would like to present about my group assignment. The title given is Application of Differentiation. My group member list is Fijan, Faidi and Nazir. What is application of differentiation? Application of differentiation is we use the derivative to determine the maximum and minimum value of function. Example, cost, strength, amount of material used in a building, profit and loss. Derivatives are made in many engineering and science problems, especially when modeling the behavior of moving objects. Now, what the usage of application of differentiation? Differentiation and integration can help us solve many types of real-world problems. We use the derivative to determine the maximum and minimum value of particular function. Example, cost, strength, amount of material used in a building, profit and loss.
So this is the example of the question of apply maximum and minimum problems. A cuboid has a volume of 8 meter cube. The base of the cuboid is square with sides of length x meters. The surface area of the cuboid is a meter square. Question 1, show that a equal to 2x square plus 32 over x. Question 2, find the a over the x. And question 3, find the value of x which give the smallest surface area of the cuboid, justifying your answer. The steps for solving maximum and minimum problems is: first, draw an appropriate figure and label the quantities relevant to the problem. Second, find a formula for the quantity to be maximized or minimized. Identify the quantity to be maximized or minimized as a function of one variable. Third, find the value of s when dy over dx equal to 0. 4. Find the d squared y over dx squared and substitute x from 3 to different between maximized and minimized value. 5. To determine the value of y, whether maximize or minimize, substitute x into y. First, we need to draw a cuboid for the diagram that from the question. After that, we label for the x and h. So from the diagram, we know the volume. Formula of the cuboid is V equal to x square h equal to 8. So for the area of square that on the top and bottom, we use x square because it have 2, so we put it 2x square. And area of the side of the cuboid is rectangle, and we can get the area by we divide x and h. So we, because it have 4 sides, so we plus with 4xh. And then after that, we don't want the h and we want the x, because we want to the equation just have x and not h. So we rewrite the equation from x square h equal to 8 to h equal to x over x square. After that, we substitute h into x from the equation 2a equal to 2x square plus 4x h. So we get 2x square plus 4x divided by 8 over x square. Simplify it, we get 2x square plus 32 over x. Question 2 is find dA over dx. From this, we just differentiate it with dx. So we get the answer is 4x minus 32x square minus. And for question 3, we want to find the smallest surface area of the cuboid. So first we write dA over dx equal to 0. Simplify it, to find s, so we get the answer s equal to 2. But we don't know the x equal to 2 is maximum or minimum. Differentiation the for x minus 32 x square minus, and we get d square a over dx square. After substitute x equal to 2 to d square a over dx square, we get 12. It is a positive number, so it is a minimum. So the question number 3 was answered.
For the conclusion, from our slide of this topic, you should know, be able to understand the idea of the differentiation from first principle, differentiate power function, find stationary point of some function, determine the nature of some stationary point using either the first or second derivative test, understand and work with derivative as rate of change in mathematical models. Thank you for spending your time to watch and listen our presentation.